Hi, this is going to be a quick talk on moving around and manipulating files in the Unix directory tree. If you're used to using a Windows or a Mac, you will probably have heard of the term folders. Folders and directories are exactly the same thing. So if you're ready, here we go. So I'm logged into a Unix system now, and I'm logged in as a user Frank, and I will be in my home directory. I can print out the directory that I'm currently in using the pwd command. pwd. Unsurprising, it's in /user/home/Frank. Now if you look at a typical tree, although this is very much abbreviated, you can see that home directories for Tom and Mary are under /user/home. There's only two of them. pwd prints out the directory. To change your working directory, it is in fact chdir, although you can also use the abbreviated form cd. And if I want to change directory to user home, I can type cd /user/home, and in the command prompt here you can see that it actually lists where I currently am, but if I want more reassurance I can just type pwd again. Now from the home directory I should expect to be able to see the list of users if I list the files. Now to list the files out, you use the ls command, which is short for list, and it's similar to the dir command on DOS or Windows. And if I type ls here, I can see there's back target, which is nothing, which is a special kind of user. There's fjl, which is my normal account, and I've got Frank, and I've got Mary, and I've got Tom. To change directory from here down to Frank, I'm just going to type cd Frank without the slash on it, and cd will start looking in the current working directory to see if there's a directory that matches where I want to change to, and if there is, it will take me there. That's the default behavior. Some Unix systems look for the directory you're changing to in a different place, but most of the time you'll find it's like this. Okay, so I'm in the Frank directory, and I'm just going to list the files that are currently there with ls again, and you can see that they are a list of file names. Really, it doesn't tell you very much about them. If you want a bit more information, you can give ls a command argument or option or something, -l. That's ls-l, and it will produce a list with a lot more information on it. And you can see it's columns with all of this stuff followed by the name of the actual file. That's a bit to unpack, so I'm just going to take us over to here where we can see some of the items from it. Now we're starting off with this business around here, which are file flags or permissions, or they have various names. They're not strictly speaking flags, they're attributes, permissions. I'm going to ignore that one for now and take a look at this first. Okay, so the first thing here is the owner of the file, that's fjl, that's me, and the second is the group that owns the file, which is devs. So a file has two owners. It can belong to a group and it can belong to a user. There's another file here that belongs to group wheel, which is an administrative group, and there's root, which is an administrative user who happens to own that file there, which is part of the operating system. The other fields here, well, that you might have guessed is the length of the file, and this is fairly obviously the date and time that the file was last modified. For older files where it's more than 6 months or so ago, it will actually print out the year and not bother with the time. And finally, these are just the names of the files. Now, these are a little bit more complicated. On a Unix system, the files can exist more than once in the directory under different names. Bit beyond what we're going to talk about now, but this is the number of times that that file exists in the directory. In fact, most of the time it will only be one. That is in fact the hard link count. But I said we'd get on to the first column, and that's what we're going to do right now. Okay, so looking at this example, the dashes and letters are actually each representing a particular attribute for this file, and they're broken up into groups. There's the first one, and then there are 3 groups of 3. Now the initial attribute here, a dash means it's a regular file. If it's anything other than a dash, it's not a regular file. The second group are the permissions for the user or owner of the file. User is sometimes used in Unix, where owner would perhaps be the more appropriate word. And that has 3 things, 2 of which are set. It's got the R set and the W set. R means that the user or the owner can read the file, and W, as you might expect, means that the user can write to the file. The third one is the X bit, which means that the file is in fact a program, but this is not a program, this is just a regular file, you can't run it, so that has a dash on it. So the first group is for the owner. The second group are the permissions for the group. So this file is in the devs group, and that means that anyone else who is in the devs group can actually read the file. The third group here is exactly the same thing, read, write and execute, but they're all 3 turned off. That means nobody who isn't in the devs group or the owner can do anything with this file. They can't see it, they can't read it, they can see it, but they can't read it, they can't write it, and they can't run it. Now we come to the actual first attribute. So we're looking at another entry here, and that actually has a D as the first attribute. What does it mean? It actually means that this is a directory and not a file. And in fact its name is the debug directory, where the debugging files are. So other things that can go in there, dash, as we already know, is a regular file, D is a directory, C is a character device, which is a basically hardware, because with Unix you can have a device, and any kind of hardware appears in the directory tree because everything is a file, and every file is a device, and every device is a file. So character devices are very common on Unix. Could be a character terminal, or these days disks are also character devices. In fact, the other type of device, which is a block device, you will hardly ever see. Then there's S, which is a networking socket, which, if you're familiar with IP networking, you would know what a socket is. A socket can be given a name and exist in a directory. And in older versions of Unix you had a thing called a named pipe, which has, for the last 20 years at least, been replaced by sockets. Other strange things you might have, as I said, block devices. They were actually pretty dangerous. If the power went down on a block device, you lost most of the data, so they're not used very much anymore. and W is a whiteout entry, which is a hangover from a very old version of Unix called Plan 9, which used things called union file systems, which complicated matters a lot by allowing you to mount one filing system on top of another, and that led to irregularities if you deleted a file. Which file was it, and could you recreate it, and did you want the file of the same name on a different filing system to appear when you deleted the old one, and it all got very complicated. So this a whiteout file is actually a file in the directory that holds a place. It contains no data, you can't read it, you can't write it, and you can't overwrite it. So if you deleted a file on an overlay directory, it would be used to put it there. But anyway, it's very rarely found on modern systems. There's one thing missing from this slide, which is the L, which you might find in the initial position, and that's actually a symbolic link. We're not really going to cover links at this time, but they're quite similar to the windows.lnk files, but much more deeply embedded in the operating system. Now we switch back to our terminal, we can start introducing some other commands. Okay, so you've got directories. How do you make a directory? It's very simple. It's the mkdir command, make directory. So we're just going to make a directory here and we're going to call it test. Why not? So I've created a directory called test, and if we list the files again, we can see that we have a test directory. We can't tell it's a test directory because it looks the same as any other file. We could obviously, if we did a long format listing, we can find it somewhere. There it is, and you can see it has the D flag set. Or there's another option halfway if you use ls with the -F option. And you can see over here that it has created or listed the directory with a slash after it, and that indicates that it's a directory. The -F option will also highlight other files that are executable by sticking a star after it, or if it's a link, by putting an @ after it. And it's quite useful if you just want some indication in a straightforward directory listing of what the file type actually is. So let's just change directory into test. Whoops, could help if I typed it right. And if we print the working directory, we can see we're there. So inside this test directory, we're going to have a little bit of fun. How do you create a file? Well, normally you'd create a file, or an application would create a file. I'm just going to run up the text editor, and I'm going to run, the text editor is called vi, and I'm going to just call it my file. So we've opened up my file, and I'm going to type some stuff in it. There we go, and I'm going to save it. Don't worry about how you operate vi, it's just one of those things you'll have to do. So if we do a ls now, we can see we have my file there. Let's get a bit more detail. ls-l, there we go. So there's my file, it's owned by me, it's in my own group, and I can read and write to it, and everyone else can read it. How do we display the contents of my file without loading it into the editor? Obviously loading it into the editor would do very nicely, but one way of doing it is the cat command. This is quite similar to the Windows or MS-DOS type command. So if I cat my file, there we go. Hello, this is a very nice file. That's alright for very small files. Cat, by the way, stands for concatenate, and in fact it will produce output that is the input of lots of different files. It'll concatenate them together, but everyone's rather confused about that. It's nothing to do with felines, it's actually concatenate. So that's one way of doing it. If I just change directory using the ... to move one up the directory hierarchy, that's a shorthand way of doing it. I'm now back in my home directory, and if we have some of the other files here, like find.h, if I did cat on find.c, whoa, there's lots of it. That's rather too much. No, that could be scrolling. If it's a big file, that would be scrolling up there for ages. So if you just want to have a look at the top of the file, I'll just clear the terminal. If you type head find.c, it prints the beginning of the file, the first 10 lines in fact. If you want to see the end of the file, you can use tail. And guess what? That prints out the last 10 lines of the file. If you want to go through and just read it without it scrolling up the screen, you can use more. More find.c, and it prints out a whole terminal window full, and if you press the spacebar, it will move on to the next window full, and so on until it's finished. Or you can use the down arrow and scroll down it. Okay, and if you're fed up of doing it, you can hit Q to end. And of course, where you've got more, there's less. So if you did less test.c, whoops, it's find.c, isn't it? This allows you to do all sorts of things. Scroll up and down it, find things, search for various things within it, and it'll highlight them. If you want to edit it, not many people know this, you can hit V and it switches it into the Vi editor for you, which we'll just quit. So that's less, and that's probably the way most people would choose to look at text files. And Q quits out of that. Okay, so we're back in our home directory, and if we do ls, we see we've got a directory there called test. If we don't want that directory anymore, we can do rmdir, which is the opposite to mkdir. Rm is for remove. Now this is not going to work because I typed rm. Never mind, I'll type rmdir test. This is not going to work because the directory is not empty. You have to go into the directory, there we go, and delete all the files in it before you can actually delete the directory. I'm not going to delete my file because I rather like it. In fact, I'm going to make a copy of it. So here we're going to use the copy command, which is cp. Why type 4 letters when you could just type 2? And the format of this command is the name of the file you want to copy, my file, and I'm going to copy it and call it my file 2. There we go. So now if we do a directory listing, we can see we have my file and my file 2. I rather enjoyed doing that, so I'm going to do it again. And I'm going to create my file 3. Wow, we're getting a lot of files here. Let's just do a long format listing, and there you can see we have them. They've got slightly different timestamps on them because they were copied at different times. How do we get rid of a file? Well, that is, you might have noticed, is the rm command. That's for remove. So I'm going to get rid of my file 2. And there it goes. I enjoyed having it, but it's taking up too much space. If I was to delete all of those, well, I'll show you how you can remove a directory. Okay, here's a directory called test2. There it is, you can see. and you can see from here that it is in fact a directory, and rmdir test2 will get rid of it for me, so now it's gone. There is a way with rm of deleting directories and all the files that are within them and all the directories that are within the in the directory, and just totally causing carnage. I'm not going to tell you what it is now, you can go and look it up, but it is much safer if you use rmdir, which will just stop and refuse to delete files that have got directories that have got files in. And if you go into the directory, you can then delete the files and you know what it is you're getting rid of, and you don't have any unfortunate accidents. Right, now, so we have copied a file. What we haven't done is rename a file. So I'm just going to clear the stuffer here out the way, and I'm going to do ls-l, and here are our two files. My file 3, I've decided I want to call that another file, and I'm going to use the mv command for that. That is move. Again, why use 4 letters when you could use just 2? So I'm going to move my file 3 to another file, and if I do a directory listing now, you can see it is now called another file. It's exactly the same file. If we type out its contents, it's exactly the same, but it's just got a different name. I'm going to create a new directory and show you something else with move or copy. The same syntax works with both. If I move my file to new, hopes if I type it right. If I type move my file to new, doesn't come back and complain, but if I do an ls-l, I've got the new directory that I created, and I've got another file here. If we get a list of what's in new, it's another thing that ls can do. You give it a directory name, it lists the contents of the directory. ls new, and there it is, my file. Let's just do that again with an L in it. There you go. So my file is now in the directory called new. If I want to move it back out again, I can do new my file, I'll type it right this time, and I can move it to somewhere else. How do I move it to my current directory? There's a special code for current directory. It's just a single dot. So wherever you have got a source and a destination, if you use dot, it means the current directory. So I'm just going to move it back in here, and there it is where it's supposed to be, and the directory new is now empty. I can prove that by deleting it. rmdir new. So we've had a look at the mv and cp commands, which of course have a lot of options, but we've just used the basic ones. What I haven't said is they actually take a list of source files. So if I have a look here, I could say we need a directory, mkdir new, shouldn't have deleted it. If I want to move both of these into new, I can type mv another file, my file, new. So what's going on here is that's the destination, and every other file on the list is a source. So it'll go through and do one after another. That's great if you're going to deal with a large number of files. And if I just move back to the main directory here, we've actually got quite a large number of files. So supposing I wanted to put anything that was to do with find into a directory called find stuff. I can do this. Find stuff, make a directory first, and then mv find.star find stuff. What is this .star all about? Well, I'll go back and I'll do an ls find.star, and you can see it lists only the files beginning with find dot. And this is a very shorthand way of specifying a large number of files by a pattern, and the pattern works as follows. The star means it will match any 0 or more characters in the file names that it is trying to match. The so find star will match find.1, find.c, find.h, find.o. If I did ls find, I'd get pretty much the same stuff, but it's also, oh, I've spelt find stuff wrong. It will also list the directory find stuff as well. If I want all the files beginning with m, I can do ls m star. It's got main.c, main.o, misc.c and misc.o. Fair enough. If I wanted to list all of the files with the letter n in, I could try star n star. So all of these files have got the letter n in them somewhere. And I can use that to create a list that I can provide to copy or move. I'll do that in a minute as a demonstration. So the other pattern matching character is the question mark, and that matches one single character. So there are not many great examples here that I can use for it, but if I did ls s star, that matches the fact that there is an L there. So the first letter can be anything you like, as long as the second letter is an S. If I was to do this with ls m star I star, it's going to match main.o, but not anything else, not misc or anything like that, because it has to match a single character. And the best way is for some fairly contrived examples, which I'll just talk through now. So the process of converting your specified pattern into a list of file names is called, for historical reasons, globbing, after a function that was glob, which actually meant global in the original version of Unix. And you'll find the word quite often used for matching a number of possible words against a pattern involving stars and question marks and some other things. So the best way to do it is to look at some examples. What would star.h match? Well, it's not going to match test.c because that's got nothing like it. stdio.h? Yeah, it probably would, because it doesn't care. This is a load of don't care, but as long as it ends in a .h, that's a good one. What about hello.c? That begins with an h, but no, there has to be characters. Well, there doesn't have to be characters before it, but there has to be a dot before the h, and then no more characters, so it's not going to match that one. What would RE match? Well, Let's have a look. RE and then any number of characters, I don't care. So RE, yep, that's fine. Rerun, that would be no problem. That would be included. Rerun.c, yeah, why not? It's just a number of characters. Run.c is a number of characters following it. How about this one? That's a bit tricky because Unix uses case-sensitive file names, and a capital R is not the same as a lowercase r, so that would fail. If you wanted to, for example, specify READ and READ with a upper and lowercase letter, you could always make the first character in the match a question mark, which means there has to be a character there, but you don't care what it is. And finally, this one down here, R, would that match? No, it would not, because there is no E following it. If there was an E following it, it would be fine, but because there isn't, it's only one character, that's not going to buy it. Now we're getting a little bit more tricky. We've got ant, a question mark, and a star. So does this match? ANT, yeah, so far good. So good. What about E? Well, that's got to be any character. And lope, okay, that matches the star, matches this lot here. So that's a number of characters. Yes, antelope is good, that would match that pattern. What about anti? Okay, ANT so far, the I, that would match the question mark. Well, what about the star? Remember, the question mark has to match one character, but the star can match 0 or more characters. How many characters are there following the I? 0. So that would match. What about ant? ANT, yeah, that's so far so good, but there's no character here. The question mark has to match one character and one character only, and there is no character there, so that would fail the match because there is no question mark there, even though following it is matching 0 or more. So we've seen how to get a directory listing. We've seen how to create directories, delete directories, copy files, move files, rename files using the move command, and all about file globbing, which is something that you really ought to practice to avoid nasty accidents. And let's sort of put it together in a useful example. So if we have a look at what's in our directory, we've got all these messy C files and H files that go to make up source code for a program. So I'm going to create a directory, mkdir source. Oh, and there's some object files that end in .o, like this one here. So let's create a object directory, because we can provide a list of things. Make directory doesn't have to just make one. This is not MS-DOS here. So that's created a source and an object directory, and I want to move all my C files into the source directory, mv star.c, and while we're at it, star.h to the source directory, and mv star.o to the object directory. Now if we do an ls, we've got much less stuff knocking around in here, but we've got a source and an object directory. And just to prove that it's worked, I'm just going to do ls-l source. Okay, so that all our source files have been moved into the source directory. There's a few more tricks that ls can do. Remember when we had a slight problem with test files beginning with f, and there's find stuff and there's find. So if we did an ls of f star, we've actually got the find stuff is listing the listing that as a directory. If we want to do ls-l f*, again, no, that's not quite what we want. We want to know about the find stuff directory itself. So ls-ld f*, D means it will print out directories rather than going into the directory and printing out the contents of them. So here we have our directory find stuff. That's not the size in bytes, that's the size in blocks of the directory, but otherwise that's there. So let's go into our source directory and have a look at this. We can actually, as you can see, it's sorting them into alphabetical, or in fact it's sorting them to ASCII order. So a capital letter comes ahead of a lowercase letter. So that sorted them quite nicely into alphabetical order by default. If we do ls-lt, that sorts them into time order. So the newest files are at the top and the lowest and the oldest files are at the bottom. We can reverse the order of any sort by adding a R into our command. So ls-lt-r. That's the same, but the new files are at the bottom and the old files are at the top. Now, these file lengths are a little bit difficult to read, especially as they're getting a bit long, too many bytes there. So if we add an H, that changes the file sizes into human readable format. So it'll give it in kilobytes and bytes. So we can see that that file there is 28K, that's 6.9K. Just slightly easier to read. There are a large number of options for the ls command. In fact, there's a ridiculous number. If you look at the manual page for it, which you get by typing man ls, if you want help on any Unix command, you can get the manual page by typing man and the name of the command. And there it is. Look at all those options. We could be scrolling through those for absolutely ages. I could talk for 2 or 3 days on ls probably if I really wanted to, but I'm not going to, you'll be relieved to know. So there's one other thing that we haven't done, and that is changing the file permissions. So again, let's have a look here. So these files belong to me and they're in the devs group. I want to change all the fbas files to not be in the devs group. I want it to be in my personal group called Frank. So the chown command is the one for that. So chown, now Frank, so I'm going to put it into my own group. That's the username, that's me, and that's the group name, and I'm going to call fbas everything. That'll give me a list of those and it will set them. So if I have a look now, the usernames have changed from Frank Devs to Frank All Mine. There you go. What I can't do is change the username to somebody else. So I can't make this file belong to Mary, and I'll just prove that. Chown Mary fbas, nah, not permitted. If you could do that, wouldn't it be handy? You could dump files in other people's ownership, and then they get into trouble when you ran out of disk space. Thinking, no, it wasn't my file, it's not my huge file there, it belongs to Mary. No, so it doesn't let normal users do that. You can do that as the administrative user, but not as the standard user. So this time I'm back as the administrative user, known as the root user, and I'll just demonstrate how you can change files to belong to anybody you like. So I'm going to change fbas.c so that it belongs to Mary. So chown fbas.c, whoops, Mary in devs. And there, if you have a look at it now, it belongs to Mary in devs instead of me. But that's something you can only do as a root user. Now, that's how you change ownership. How do you change the file permissions? And this all gets a little bit complicated. That's done using the chmod, which is file that's change mode, which probably really should be saying change permissions, but for historical reasons it's the file mode. So fbas.c is owned by Mary in devs, and she can read write it. If I want everyone to be able to read and write it, I use a command like this. G plus w fbas.c, and if I just list it again, you can see it's added the W flag to it. And so how has this actually worked? Right, the plus here means that you're adding something or rather than removing something. And before the plus I've got G, which is group, and after it I've got what I want to change, which is W. And you can have in front of the plus you can have U for user, G for group, and O for other permissions, and after it you can have read, write, and X for executable, not E, X. So if I want everybody to be able to do everything, I can do chmod user group other, and I want them to be able to read, write, and execute, which is a bad idea because it's not a program. And of course Unix will let me do it, because Unix will let you do anything crazy just by asking. So all of the permissions are set for everybody. Bad idea, but anyway, if I do chmod a minus x, that's going to turn off the X permissions for everybody. A is a shorthand for what I have done here, which is user group and owner. So I'll have another look now. Okay, so now everyone can just read and write it. And if I want to make others unable to read it, if I want to make others in the group and others generally unable to read it, the command would be chmod group other minus write. Oops. Okay, there it is. So only Mary, oh, it actually belongs to Mary still. Mary can read, write it, everyone else can't. And yes, you can make a file that you can only write but not read to. Unix lets you do it. Not terribly useful. Okay, chmod is quite complicated. It can do it in lots of ways. I've tried to make it as simple by explaining the simplest way of doing it, but the best way to do it is to actually log in and have a little play around with it on files that are yours and that if you manage to lock yourself out of, you don't care. Okay, and a few more other little tricks. CD is quite handy. I'm in CD slash Frank, well, where am I? I'm right here. So I can do CD to wherever I want to. I can go CD slash USR, see where that is. Got all of that stuff there. I think I want to go back to where I was. You can just type CD minus and it takes you back to the directory you were last in. Very useful trick that. On some Unix shells you can push and pop your location, but you can always use CD dash. If you just type cd with nothing after it, and bearing in mind I'm the root user here, it will take you to your home directory. I'll prove that. I'm in the root user's home directory now. cd dash, it takes me back to where I was before. If you want to move up one directory, I have mentioned this, you can do cd dot dot. If you want to move up two directories, you can cd dot dot slash dot dot, and that moves you up two in one go. Let's just move ourselves back. If you want to go to your home directory, well, we know how to do that, and the tilde character means your home directory. If you want to go to somebody else's home directory, you can do cd tilde Mary and see what Mary's got going on here. So Mary in her directory, she's got a load of files. They all belong to Mary, and she has got a directory called plans. We can have another little nosy at that. Plans. Okay, she has two plans, for a party on Saturday and for world domination. Let's perhaps leave Mary alone. So that's a couple of little wrinkles with CD. And is there anything else? Right. Okay, so how do you back up files? Well, if you're going to back them up to a tape drive, there is the tar utility. So I'm just going to switch back to the Frank directory. There we go. And if I want to back up all my source files, I can quite simply do it. tar is the name of the utility, tar, and it takes a number of options. So I'm going to create a backup, and I'm going to tell it what I want to back up. I'm going to back up my source directory, and I'll back up my object directory as well. So off it goes. Whir, 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 clunk, clunk. There is the sound of a tape drive coming into action, and it is going to come back in a second, and there we go. It has actually written to the tape drive. By default, it will write it to the serial access device 0, or if you have more than one, you can specify that. You can also make it write its output to a file. So let's just prove it. To get it back from your directory, or to find out what's on your tape, you can type tar-t, and there we go. It's found that very quickly off the tape. And tar-x will get stuff out. You can use tar to write directly to a file, so I could do tar-cf followed by a file name, my stuff. I'm just going to call it .tar so that we know what it means, and I'm going to give it the same stuff. Okay, so now if we have a look here, we have a mystuff.tar which contains the source and object directory. We can have a look what's in it. tar-t my tf, because we're giving it a file. It's mystuff.tar, and again it gives me a listing of what's there. If I wanted to extract it, it would be an x, but it would just simply overwrite what I've already got there. So tar is a bit like zip if you use it with a file. If you use it with a tape, it just naturally writes stuff to and from the tape drive. And you can control the tape drive with the magnetic tape utility, which, being a two-letter system, is MT. So you can do MT, rewind the tape. That means that if I write something else, it's going to overwrite the stuff that I've put there before. Again, have a look at the man page if you're dealing with tape. Not that many systems deal with tape now, especially virtual ones, because you can't really have a virtual tape. But the tar utility is useful for creating something similar to a zip file. you can copy the tar file to somewhere else and then unpack it using the tar-x option. In fact, let's just do that. mkdir demo, I'm going to go cd demo, and I'm going to unpack that tar file, tar-xf. It's one directory above now, my stuff.tar. Very quick. Now if I have a look in my demo directory, I've got a copy of the source and object directory that I had before, and you'll notice that timestamps on everything and the owners and everything else about it has remained exactly the same, which is not something you get from a zip file. Okay, that just about wraps it up. I hope you found it useful. If so, I will do another one on mounting and filing systems, and maybe even one on ZFS. So it's been an interesting experience. This is the first time I have done a online demo like this, and if it works out well, it won't be the last. Thank you and good night.